Good afternoon. So all the previous lecture PDF has been uploaded. You please check. And real axis root locus, all the notes are uploaded. You can find it in the lectures. And experiment number 7A, that is also uploaded. You can find the same thing in Google Classroom. So please check. So here today we are going to do a very important topic. So we are launching this from GIT itself. We have started coming to college. So what we are important part. So real part of root locus is almost done. We have understood. Uh, I have posted some 19 different root locus plots in my document. So solution, how to solve it. This is one aspect. How the root locus will look. That is another aspect. So how it will look, if you know that initially, then it is easier for you to calculate. So this MATLAB coding and MATLAB output and calculation should go hand in hand. And some student asked me yesterday, sir, can you post some numerical? So I say for real root in the left side. You can just take any value. So the roots or poles you can take as 2, 7, 8, 9, all negative, and you can plot what is the root locus. If there are three real poles, you can take poles are minus 100, minus 200, minus 300. You can plot what is the root locus. So you can generate your own numerical and you can keep solving. So I have posted in my document only 19 root locus. All those same things you have to do, but same type of thing with changing the root points. So all the instructions are given in my experiment 7A message. So please check that. Only one thing is remaining. Actually, rather two things are remaining. So one out of that we will see today. What is that? That is called as how to calculate the step number 7. That is angle of arrival and angle of departure. First, you have to understand when these things appear. Angle of arrival appears when there is a complex 0. So whenever there is a complex 0, at that time root locus appears or comes back to a complex 0. So in that case, it comes with a certain angle. That angle is called as angle of arrival. And whenever there is a complex pole, so in this case you are finding that I have given you a numerical. So you should start with this numerical, that is GSH is given by k divided by s into. Now these are the poles, minus 2 plus 2j and minus 2 minus 2j. So you can find that there are three poles in a system. One pole is a real pole, that is at origin. Remaining two poles are complex poles. So one pole is at minus 2 plus 2j, that is this one. Another pole is there at minus 2 minus 2j. What will be the root locus looking like? Okay, so one root locus we are finding that it is starting from 0 and going up to infinity. So this one is a stable root. This one is a absolutely stable root. That is when k is equal to 0. This root is at origin. It is little bit less stable. It is marginally stable now, but rather it is stable. And little bit increment in the gain of k, and you will find that this root locus will keep on going to the negative side. From this GSHS, you are finding that GSHS is having three poles and no zeros. So whenever we are finding there are three poles, that means there will be three root locus which will go to infinity. So this S, which is starting from 0, this is one angle of asymptote. So now there are three poles. Three poles means there are three angle of asymptotes. One is 60 degree, one is 180 degree, another is 300 degree. How to calculate? We have seen the beta formula last day. So this is that second asymptotes, that is at 180 degree. That means this pole, as you are increasing the gain k, this will follow the 180 degree line and it will go to minus infinity. So this problem is solved. The rule you can apply, the rule was just check the right side of any pole, and if you're finding that at the right side of any point is having total number of pole and 0 is odd, then that is a root locus. So just check this point 1. So this point, this root you can find from the numerator, that is s is equal to minus 2 plus 2j is one root, one pole. S is equal to minus 2 plus 2j is another pole. So these two are the poles, complex poles. And whenever there are complex poles, all the steps will be there. Plus seventh step also will be there. Seventh step is the uh, calculation of angle of departure. Angle of departure is nothing but from that pole, the root locus will start and it will create an angle. So what you will find is how the root locus will look like. I will show you in one shot, because initially if I'm showing you, then it becomes easier for you to understand. So this is how the root locus will look. No? Is it visible? Can anybody confirm? Is it
Yes,
still
yes.
visible? Okay, there was a power cut temporary, so that's what I'm asking. Fine. So this is how the root locus will look like. This real root will go from here to the infinity as k is increasing. Okay, and these are two complex poles. One is minus 2 plus 2j, another is minus 2 minus 2j. So one root locus will leave from here and it will leave with the angle of departure. And in this case, we have calculated that angle of departure is minus 45 degree. How to calculate it? I will show you. Minus 45 degree means always we count from positive side of x. So if this is the point, you have to draw angle of minus 45 degree. So for that, first, whenever I give you a point, so now I'm entering something which is a pure common sense, but student are to be told about that. So if I ask you to draw an angle of 45 degree from here, what is the first thing you have to draw is from this point, you draw a a line to the right side. So whenever I'm asking you to draw a angle from any point, first thing you have to draw is starting from that point, draw a line to the right side, any point. So I ask you to draw an angle of 90 degree here. What you have to do is first you have to draw a line of uh, x-axis. That means from here first you have to draw a line in the right side. Okay, like this. This is called as positive x-axis. So from here also, if I'm asking you to draw a line, draw an angle, first you have to draw a line. And with that line, you have to draw the angle minus 45 degree. So 45 degree negative is coming below, 45 degree above is coming positive. That means whenever we are drawing anti-clockwise, that is actually positive angle. And whenever we are drawing clockwise, that is a negative angle. So what was the question? I have found that there are three root locus because there are three poles which are given. The poles are given at first initially pole was there at 0, and then there was a poles minus 2 plus 2j and minus 2 minus 2j. So for minus 2 plus 2j, we will calculate it. How to calculate, I will show you. For minus 2 plus 2j, that is this pole, we will find that angle of departure is minus 45 degree. So you will not have to calculate angle of departure for both the poles. For one complex pole, if you are finding angle of departure is minus 45, automatically for the other complex conjugate pole, the angle of departure will be plus 45. So if we find that there is a set of complex conjugate pole, you have to find angle of departure only for one pole. Angle of departure for the other pole will be negative of that. So this is another thing. In this case, we are having two complex conjugate poles. For first complex conjugate, so either you can find below one or you can find above one, doesn't matter. If we are finding above one and if we are finding that angle of departure is minus 45, आंखें बंद करके तुम लिख सकते हो that for the below, the angle of departure will be plus 45 degree. In exam also, you will not have to find for both. You have to find out for one, provided you have found it correctly, and then you have to say that for the other complex conjugate pole, the angle of departure will be negative of that. So for top one, if you have found out to be minus 45, for bottom one pole, angle of departure will be plus 45. I have checked only 10 papers of your IA, but one very wrong thing I am finding in students, many of the students have written all the questions. That is a very bad practice, never do that. If you are little doubtful, you can say it's an extra attempt and you can solve, but don't try to show your, don't try to do show off in the exam. Okay, so if you are solving both the things, if I've asked you to solve one question from suppose I have given you two and I have asked you to solve one question. If you are solving both, okay, and one is perfectly right, another is perfectly wrong. Examiner, if he wants to create some nuisance, he will take the wrong one, he will give you 0 marks, and he will go out, and nobody else in the world is going to check that. So if you want to show your expertise, if you really want to show you are very well prepared, whichever numerical or whichever question you are answering, answer it perfectly. Don't try to take chances. So if one you have to answer out of two, answer the best one whichever you know correctly. Never answer both. It means that you are not you are sure neither of these two. So in that case, examiner has every right. Generally, we don't do that. But if he gets annoyed, he can do what? He can give the 10 marks in the first one, which is completely correct. Next one is wrong. He will give 0 marks. And in these two questions, he will consider only the 0 mark and he will go forward. So don't do show off in the exam. You have to do show off, yes, within your limits. The questions you are answering properly, the questions which are asked mandatory, there you can do all the show off. You can give best answer, perfect drawing, label, diagram, coloring, these, that, all those things. But don't make the examiner work unnecessarily. In this case also, if I'm finding that for the first top one, angle of departure is minus 45, no need to calculate. Okay, for your confirmation, you can calculate what is the angle of departure for the bottom one. वो side में rough में अलग से करो. In the same numerical, don't find angle of departure for both the complex poles. I think the matter is clear, whatever I am trying to say. But if you are not sure that, okay, whatever angle of departure I have found at top, whether it's correct or not. So if this is minus 5, let me find out for this also, and let me find out this is 45. So it's a double check, double confirmation. You can do that, but do it in a separate place. And you get that, yes, for the below thing, it is plus 45, fine. So top one minus 45, bottom one plus 45, cross check done, go forward. But don't do this thing. So overwork, we don't appreciate. So this is how the root locus look like. So there are two complex poles, one a real pole. So from the real pole, apply the same logic. That is at any point, let's say minus 1. Whether minus 1 real root locus lies on minus 1. We have to check that. So check minus 1 point. So this point is minus 2 wherever roots are there. So this point, okay, this point you directly plot below. So this is minus 2. Here it is minus 1. We have to check that whether minus 1 real how do we check that? We check at the right side. From minus 1, we check to the right side. Right side, how many poles and zeros are there total? So one pole and no zeros. So to the right side of minus 1, if you really want to write about, so to the right side of point minus 1, we are finding total pole plus 0 is equal to 1 plus 0 is equal to 1, which is an odd number. Hence, minus 1 will be on root locus, or root locus will be there at real axis on minus 1. Same thing happens at point 5. Same thing happens at minus 1.5. So if you're taking minus 1.5 or zero point 0.5, look at its right side. Total number of pole plus 0 is equal to 1, which is an odd number. Hence, in between 0 to minus 2, every point, if you do that, it will be the same logic. So either you take minus zero point 0.1, or you take minus zero point 0.5, or you take minus 1, or you take minus 1.99. For every point, look at the right side, you will be finding that odd number of pole plus 0 is there. That means 0 to minus 1.99, root locus is existing on all these points. Now you take less than minus 2. Less than minus 2 means minus 2.1, minus 2.3, minus 3, minus 5, minus 10, minus 100. All these points are less than minus 2. So let's take minus 3. Now the question is whether root locus real axis will be there present at minus 3 or not. So check the right side of minus 3. So this is the minus 3 point. Minus 3 point means minus 3 plus j omega infinity up to minus 3 minus j omega infinity. So whenever I'm saying minus 3 point, that means this whole line which is parallel to j omega axis and passing through minus 3. So there's a shifted y-axis kind of a thing. So all this thing. Whenever I'm saying minus 3 point, and you have to check whether root locus is lying on real axis at minus 3. So you have to check its right side. Total how many poles and zeros are there? A real pole as well as imaginary pole. All these three things. So this numerical is that's so special. So I want to check whether root locus is lying on minus 3 or not. So look at the right side. How many poles are there? So one pole, two pole, and three pole. Okay, so don't get confused कि सर ये क्या है, ये तो ऊपर है, but it's okay. Whenever you are saying right side of minus 3 means this minus 2 plus j2 and minus 2 minus j2, they are also lying in the right side of minus 3 point. That means minus 3 point will be on root locus, or real axis root locus will be there on minus 3. Same thing happens for minus 4, minus 5, minus 6, minus infinity. That means 0 to minus 2, right side, any point right side, there is only one pole which is a odd number, hence root locus will be there on 0 to minus 2, and minus 2 to minus infinity. Look at the right side, you will be finding three poles. 3 is an odd number, hence minus 2 to minus infinity also root locus will be there, real axis root locus. So what is the logic overall? That means we are finding that overall real axis root locus will start from 0 and it will go to infinity. That will be actually the locus of this absolutely stable pole, which is starting from 0 and going to minus infinity for increasing value of k. Second root locus will be starting from minus 2 plus 2j, and as angle of departure is minus 45, this will be restricted within minus 45 degree angle. So this will take a bend at minus 45, then it will go up, and eventually we will calculate that what is k marginal. So k marginal you are calculating at omega marginal of 2.82. So this is the 2 plus j2, that means this is 2j, and above actually this will be 2.82. That means while crossing the j omega axis, this root locus will cross this 2.82 radian per second. Okay, that means it has to go up, but it will go up first, it will take a dip. First it will take a dip of minus 45, because minus 45 is the angle of departure, and then it will go up and it will cross the j omega axis at 2.82 radian per second, and at that point you will be finding that k marginal will be 32. If you're talking about the bottom pole you will be finding that angle of departure is 45, and again you will be finding that this bottom omega marginal will be minus 2.82. So if you connect these 2 points, you are going to get the root locus, and for increasing k it will go up to infinity. So it will start at phi d minus 2 minus 2j, then it will go up with an angle of plus 45. Okay, so this is that plus 45 guideline. This is actually the guideline for angle of departure. So from here you have to draw a plus 45 degree angle. What is plus 45? It is nothing but the angle of departure. So this will take an angle, this will take an angle of plus 45, then it will come and it will cross through the minus 2.82 line. Minus 2.82 point, because at 2.82, minus 2.82, I'm sorry, at minus 2.82 what's happening is this is called as angle of departure, and that minus 2.82 is nothing but the negative crossover frequency, that is the omega marginal at negative side. So this is looking very easy. This looks also very nice because it's even with respect to the x-axis. But while drawing, there might come many confusions. What is the confusion? Here you are finding that centroid. So there are three poles. One is real pole, two are imaginary poles. That means you will be finding that, and there is no zero. That means there will be three asymptote lines. As there is no zero, that means p minus z is equal to 3. That means there will be three asymptote lines. One is 60 degree, one is 180 degree, another is 300 degree. That means you have to draw these lines. So sigma c will find as minus 1. Okay, so how do we find sigma c? Divided by 2. So this thing is minus 2 plus j2, and below is minus 2 minus j2, and divided by p minus z. So p minus z is coming to be 1.33. I made a mistake. I said sigma c is at minus 1, but sigma c is at 4 by 3, that is minus 1.33. So real part of you student, you are still joining. It's almost 20 minutes late. It disturbs actually. Please don't do this. Okay, so one real part is at minus 2, another real part is at minus 2. This third pole is having no real part. So this is minus 2 plus minus 2, that is minus 4, divided by p minus z is 3. So sigma c will be minus 4 by 3, that is minus 1.33. So from minus 1.33 you have to draw a line. So please protractor and check this line where it cuts it. Check this line where it cuts it. Okay, the j omega axis. So sometime we are confused whether the root locus will be above or below this guiding line, or above or below this line which is going to be the asymptote. So still many people are not able to understand it, because as long as you are not drawing the complete root locus on your own, these are the small points that you will not be able to understand. And while doing MATLAB, you may understand the actual root locus, what is the path and all those things. But in exam, there will not be any MATLAB. In exam, you have to draw it properly. So some student, what do they do is they cannot understand and they cannot calculate properly. So they do like this. This is coming minus 45 and then this cross and draws below. Okay, and this also it goes above and cuts this and goes below. So some root locus will find that, okay, that root locus is cutting this asymptote line and joining from above. Some root locus will be going above the asymptote line, so there is no rule for that. Only thing is you have to calculate. So if it is a minus 1.33, and then you have to do tan of 60, and you know how much is the y-axis. Okay, or you draw exactly 60 degree from this minus 1.33 by using protractor. Wherever it cuts the j omega axis, it goes above. But for this root locus path, that is minus 2 plus 2j, you know that this will cross the j omega axis at calculated omega marginal of 2.82. So you have to draw accordingly. So this is how it looks like. But now question is how to draw the whole root locus. So we know the whole process. It's not difficult. One very more important thing is there is no breakaway point you can find here. Another very important point. So whenever you will be doing that step, k is equal to some polynomial in S. So there are three poles here. So we'll be finding k is equal to minus of s cube plus something of s square and all. And dk ds will be square. So in this case, we will be finding there are two breakaway points. And both our breakaway points are going to be invalid in this case. So this is another very important numerical where you have to find breakaway point and you have to prove that breakaway point is invalid. Okay, you just cannot say breakaway point will not be there. You have to prove that breakaway point is invalid. So with this imaginary kind of pole, lots of different trouble comes. One trouble is you will be finding you have to calculate breakaway point and you have to prove that breakaway point is invalid, and that calculation is big. Second thing, you have to calculate angle of arrival. You have to calculate angle of arrival at only one pole. Okay, because if there are four complex conjugate poles, that is two here, and maybe two complex conjugate poles are here. Okay, so in that case, only find for above this one. Whatever, if this is minus 45, the below will be plus 45. Then suppose if I give minus 4 plus minus 2j, there are two poles. Again, you have to find angle of departure at minus 4 plus 2j, and that will be negative at minus 4 minus 2j. So if there are six complex poles, in that case you have to find three angle of departure, and the other three angle of departure will be negative of the above angle of departure. So likewise we have to proceed, and in this case a very important thing we are finding that there are three root locus. One is starting from 0, this is the absolutely stable pole, it will go up to infinity as gain increases. Second root locus will start from minus 2 plus 2j. It will, as you are increasing the gain, it will take a bend towards negative. What will be the bend? Bend will be kind of 45. Now if you ask me, sir, ये 45 तक कहाँ तक आना है, whether I come here and then bend or whether I bend from here, इसका कोई आंसर मेरे पास नहीं है. Okay, because you cannot cross the minus 45 line and come below. That is first thing. You have to take it a kind of a curvature kind of thing. But वो curvature कितना नीचे आके लेना है, उस पे कोई rule नहीं है. Okay, calculate, but there is no point calculating. Just you have to draw a rough sketch that it has to take a bend of minus 45 below, and then it will go above, and you know what is the point that it will cross the j omega axis. So mainly you have to take a negative bend of 45 degree, and then you have to go up and pass through 2.82 radian per second. This is mainly what you have to do for the top one. For the bottom one, you have to start at minus 2 minus 2j. You have to take a upward bend, and then you have to come below and pass through minus 2.82. This is how the root locus root looks like. Now first thing is, Let us do from the very first step. Okay, so it will not be given like this. It will be given as a square plus, you can find here. So this will be s plus 2 whole square plus 2 square. That means it will be a square plus 4s plus 8. That kind of thing will be given. Okay, so one pole is at s, that is at origin. Another, this will be given a square plus 4s plus 8, something like that. It will be given. You can either apply your rule of finding square root, or you can use your calculator to find these two roots. That is, s is equal to minus 2 plus 2j, and s is equal to minus 2 minus 2j. Now first thing you have to write, p minus z is equal to 3. So in that case, as soon as you're writing p minus z is equal to 3 in exam, write in little detail. Say that there will be three root locus which will go to infinity. One will start from 0 and it will go to infinity with 180-degree line. Another will start from minus 2 plus 2j and will go to infinity with asymptote of plus 60 degree. Another will start from minus 2 minus 2j and will go to infinity with the asymptote of 300 degree. So these three things you can say after this step 1. Step 2, you have to draw the pole 0 plot, because you have to now mark what is the real axis root locus, and you have to give the logic. Take any point between 0 to minus 2, look at its right side, you will be finding p plus z is equal to 1, which is an odd number. Hence, this 0 to minus 2 will be real axis root locus. Take any point less than minus 2 and look at the right side, you will be finding pole plus 0 is equal to 3 plus 0 is equal to 3, which is an odd number. Hence, you have to find that, or you have found that, the whole negative real axis. So this is the first time we are finding like this. There is a whole negative real axis is a part of root locus. So 0 to minus 2 is one part of it, because right side there is only one pole, and minus 2 to infinity minus infinity is another part, because right side again there are three poles which are also odd number. So in two steps you have to prove that, and small explanation you can write. Though we know that student understand it well, but not in initial stage. You are still at initial stage of root locus now. Few numericals, if you solve your hand, it will be very good. So all the notes are uploaded, all the PDFs are uploaded. Whichever numerical I am giving, whichever numerical I have solved, you please practice that, solve on your own, you will be able to understand it. Now, real axis root locus is found, that is, it goes from 0 to minus infinity, no problem. Calculate the number of asymptotes. So, three asymptotes. Angle of asymptote is 180, 60, and 300. All those things are done. Centroid. So, there are three poles, 0, minus 2 plus 2j, and minus 2 minus 2j. There is no zeros, only three poles. So, zeros real part is 0, and pole real parts are 0, minus 2 minus 2. This is minus 1.33 is the centroid. So centroid point is minus 1.33. So from there you have to draw three angles, 180 degree, 60 degree, and 300 degree. Up till this there was no doubt. Now will come the confusion. Breakaway point. So breakaway point is 1 plus GSHS. That means whatever is given at the denominator, that is s into a square plus 4s plus 8 plus k. Okay. So here you are finding directly s cube plus 4s square plus 8s plus k is equal to 0. And then what you are finding is, if you solve it, so do dkds, that will be in a square. So what you are finding is, it is coming to be s is equal to minus 1.33 plus minus j 0.94 away point. Now whether these two imaginary breakaway points are valid breakaway points or invalid breakaway point, this is a check we have to do. And this is a boring kind of step, but we have to do that. Without doing that we cannot go forward. Eventually they will come that they are invalid breakaway point, because this whole numerical is not having any breakaway point. I showed you, but you have to prove that. How to prove that this breakaway point is invalid? So yeah, if you can prove one of these two, that means minus 1.33 plus j 0.94, we will prove that that is a invalid breakaway point. Automatically its conjugate also will become a invalid breakaway point. So how to prove that minus 1.33 plus j 0.94 is an invalid breakaway point? For that what we have to do is, for that we are,
Sir, your presentation is not visible.
yeah, I got it, I will just upload. So for that, what we have to do is we have to take the GSHS equation. In GSHS equation, we have to substitute any of the S. So I have taken GSHS. So this is K divided by S into S plus 2, S plus J plus 2 and J minus 2. And there instead of in place of S, you have to substitute minus 1.33 plus J.94. So for both the two breakaway points, you cannot simultaneously put both the values. So take only one value of S and put it in the GSHS equation and calculate for angle. You will not have to calculate for the amplitude, you'll have to calculate for angle. So what is the step? Step is whenever we are getting a imaginary breakaway point, in that case we have to check whether the imaginary breakaway point is valid or not. So whenever we are finding imaginary breakaway point, if we are finding two, obviously it will be coming in complex conjugate form. Take any of the values. So minus 1.33 plus j.94, substitute it in the GSHS equation and calculate for angle. The whole process is given here. You can do it by using your calci also, and you are finding that the angle, so numerator there is k means k plus 0 j, that means this angle is pure, this is 0 degree. And below, whenever you are substituting this angle, and you are going to, sorry, substituting the value of S, you will be finding that there are angles coming. This angle can be positive, this angle can be negative, doesn't matter. But what you have to check is whether these angles are multiples of 180 or not. Multiples of 180 means if this angle is coming is 180 or 360 or 540 or 720, or it is coming to be minus 180 minus 360 minus 540 minus 720, then those 2 points are valid breakaway point. If after substituting the point, that is the imaginary breakaway point in GSHS equation. So after substituting the imaginary breakaway point in the GSHS equation, if we are finding that the angle is not a multiple of 180, so it is condition is given here. So hence the angle condition is not satisfied, because whatever angle we have found, it is minus 163.75 degree. If you are substituting minus 1.33 minus j.94, this angle you will get as plus 163.75, and you have to say that this angle is not a multiplication or multiplicand of 180 or 540. So if it is not a multiplication of 180, then this breakaway point is not lying on, not a part of the root locus. That means in that case the breakaway point will be invalid. So again, I'll just sum up the whole process into two lines. That is, we have found out a complex kind of a breakaway point. There are two complex breakaway point. Any one you prove invalid, the other one will automatically be invalid. That means breakaway point is of no use, so you won't have to even draw it. How to do that? So substitute any of the complex into the GSHS equation, and whatever angle you are finding, if that is a multiplicand of or if this is a multiplied version of 180, it can be positive, it can be negative, then only that point will be on root locus. But in this case we are finding the angle found is minus 163.75, which is not anyway, it is a multiplicated version of 180, 360 or 540 or 720. In that case, hence the angle condition is not satisfied, hence both the breakaway points are invalid. So you have to calculate this, and then you have to say that this breakaway point is invalid. Next step is most important, for which this lecture has been convened: how to find the angle of departure. Angle of departure is 45 degree or minus 45 degree, but how to find that, that I am going to show. So after I launch my document, I will show you how to find that the angle of departure from the point minus 2 plus 2j, that is actually going to be minus 45 degree. Now here is the step. So first you have to draw these three poles. First pole is at 0, second pole is at minus 2 plus 2j, and third pole is at minus 2 minus 2j. What we are trying to find, very important. Now listen to this last 10 minutes carefully. All other steps are kind of repeated for us. This is the only new step. So you are finding the angle of departure at a point minus 2 plus 2j. Where are the other poles? Other pole is there at 0, and other pole is there at minus 2 minus 2j. So first thing what you have to do is, at whichever point you are trying to find out the angle of departure, we have seen the result is minus 45. We are trying to prove that. So first you join the point where you want to find angle of departure, that point with all the poles you connect. Okay, so there are three poles. Again, I'm repeating: minus 2 plus 2j, minus 2 minus 2j, and 0. You want to find angle of departure at minus 2 plus 2j. So first you have to connect minus 2 plus 2j with 0, and then you have to connect angle of point minus 2 2j with minus 2 minus 2j. So minus 2 plus 2j has to be connected with minus 2 minus 2j. Now what? So this step student are very much anxious, they cannot do it. So it is not difficult, only thing is you have to practice the numerical that I am giving, only that you practice. So if you're trying to find angle of departure at minus 2 plus 2j, join 0 and join minus 2 minus 2j with that. And apart from this, so you're trying to find it here. So below, draw this x-axis, and below draw this x-axis. So if I give you 10 poles, 10 pole means such 9 lines you have to draw at the point where you are trying to find out angle of departure, and you have to connect all the other 9 poles with that. And in the poles you are supposed to draw the x-axis, real x-axis. So first I have to connect this, because I'm trying to find angle of departure at minus 2 plus 2j. And after joining this, I have to extend it to the positive x-axis. Then I will join this, and then I will draw another angle with minus 2 minus 2j. So then after that, we have to connect what is the angle. What is the angle between the below line, that is the real part of x-axis, and the drawn perpendicular. So that I am supposed to find out. So first, actually, I'm joining this thing, that is whichever pole I'm trying to find from. Okay, from there I'm trying to connect this and drawing this line, and this is angle 5p2. That means pole angle 2. Then I'm joining this with this 0 and extending this, and then I'm finding this angle as 5p1. Okay, so this is minus 2 plus 2j, and this is minus 2, and this is 2. So you'll be finding that 5p1 is 135 degree. You are having calculators, very easily you can calculate. So this is minus 2 and this is plus 2j. That means base is also 2, height is also 2. That means this angle, whatever is there inside this angle, this is going to be 45 degree. That means if you are trying to find out 5p1, 5p1 is going to be 180 minus 45, that is 135 degree. So this is the first angle, 5p1. And then you have to join minus 2 plus 2j with minus 2 minus 2j and extend this. You are extending this means this is the angle. So from the positive side of x-axis till the line that you have joined, this angle you have to find. From the positive side of x-axis till the line you have joined, this angle you have to find. So we are finding that from the pole 1 it is making an angle of 135, and from the pole 2 it is making an angle of 90. So what is total 5p in that case? Total 5p is 135 for 5p1 and 90 degree for 5p2. So this is 135 and this is 90. So total is going to be 2 for 225. And angle of departure is 180 minus phi, where phi is equal to 5p1 plus 5p2. Actual phi angle is angle made by all the poles minus angle made by all the zeros. So in this case, as there is no zeros, in this case only the angle of poles have to be considered. So I'll repeat the whole process. There are three poles. You want to find out the angle of departure at minus 2 plus 2j. First step, join minus 2 plus 2j with 0 and extend the x-axis. This angle, whatever line you have drawn, what angle it makes with the positive side of x-axis. So you are finding that this angle is actually creating angle of 135. How so? Because this height is 2 and base is 2. So you should be having clear understanding of geometry and trigonometry. So this height is 2, base is 2. That means this inside angle is 45. That means this outside angle is 135. So this is the first case, which is called as 5p1. Second case, as there are three poles, there will be two angles you have to calculate. So from minus 2 plus 2j, you connect this line below. Okay, so this is going to be a perpendicular line, and then extend it here. So you are trying to find this angle. So extend it here, you'll be finding this line is 90 degree. So what is total 5p? 5p is 90 plus 135, that is 225. There is no zero. So what is phi? Phi is actually angle made by poles minus angle made by zeros. So angle made by poles means 90 plus 135, that is 225. Angle made by zeros is zeros. What is angle of departure? Angle of departure is 180 minus whatever phi p we have found out. So it will be 180 minus 225, that is minus 45 degree. So you have to write that angle of departure of pole S is equal to minus 2 plus 2j is minus 45 degree. Automatically we can find out that at this point angle of departure will be plus 45 degree. How to do that? Very easy, it is not difficult. So first connect this point with this line. First point this point with the origin, and then extend it. So this whole angle, so our dashed lines I have drawn later on, you can check. So this whole angle will be 225 degree, because this angle below is 45. So whenever you're drawing this angle, it will be 180 plus 45, so that is 225. This is the first thing. Second, you have to join this thing and you have to go up, and then you have to draw this line. So how much is this angle? So this angle I have shown, this will be 270. Okay, so this is minus 90 or 270. So if I'm trying to find out what is the angle of departure at phi p2, so first you have to join this with 0, and you have to calculate this angle from here to this dashed line. It is going to be 225. How to find it above? So from here you have to join above and you have to draw this. So this angle is 270. So what is the total phi p now? This is phi p1 plus phi p2, that is 225 plus 270, that is 495. Okay, so this angle from here to here it will be 225. From here to here this will be 270. If you add them, it will be 495. That means how much is going to be phi? Phi is going to be 495. How much is going to be phi d? Phi d is 190, 180 minus 495. That is going to be minus 315 degree. I'll repeat this process. Phi is 270 plus 225, that is 495. And how much is actual angle of departure below? It is 180 minus 495, that is minus 315 degree. Minus 315 means if you are starting from here, you are coming like this, minus 315 means here. So minus 315 actually is plus 45 degree. So that way you are finding that below, that is minus 2 minus 2j, the angle of departure will be plus 45 degree. So this is how we are supposed to calculate angle of departure if there is only pole. If there is only 0, or if it's a combination of pole and 0, those kind of numerical also we will see afterward. But this numerical you understand clearly. So what we have found out so far is sigma c is there at minus 1.33. There will be 3 asymptotic angles. Breakaway points both are invalid, so there is no breakaway point for this case. And angle of departure for minus 2 plus 2j is minus 45 degree. Angle of departure for minus 2 minus 2j, that is equal to plus 45 degree. So all these things we know. Now the last two things are remaining, which we will find by Routh-Hurwitz criteria. So from the above, we know what is the characteristic equation: s cube plus 4s square plus 8s plus k. You write it down. So 1 and 8 first line, 4 and k second line. Now you are finding this as 32 minus k divided by 4. So this is 4 into 8 minus 1 into k divided by 4. So that comes to be 32 minus k divided by 4. That means k marginal is going to be 32. So this is one k marginal we have found as 32. Substitute in the previous equation. So now 4a square plus 32 is equal to 0, or a square plus 8 is equal to 0. You are finding it here. That means a square is equal to minus 8. That means omega marginal is under root of 8. That is plus minus of 2.82 radian per second. So what we have found so far is, we have found that minus 2 plus 2j is having minus 45 degree angle of departure. The below point, that is minus 2 minus 2j, that will be having plus 45 degree angle of departure. This s is equal to 0 is a real root, so it is not having any angle of departure. This will be having a real root locus which will start from here and go to the negative infinity. And then we have found that k marginal is coming to be 32 and omega marginal is coming to be root under of 8, that is 2.82. So comment or result. So system is unstable for k greater than 32. We have just now found out that k marginal is 32. So such kind of comment you can write as step number 9. And system is marginally stable for k is equal to 32. That means whenever the root or s is equal to 2.82, that means whenever there is a crossover point At that crossover point, the gain is 32. So K marginal is 32, and system is stable for a K value in between 0 to 32. But the main trick in this case is not K marginal or omega marginal. The main trick in this numerical is to find out what is the phi d, or what is phi d for both the complex pole positions, and how to connect that with the K marginal at omega marginal. So first we have to draw the real axis root locus. This is the first one. Top and bottom root locus we cannot draw. So second and third we cannot draw, because second and third is for uh, complex poles. So first we have to draw the real axis root locus. The whole negative real axis is the root locus. Next we are supposed to find out sigma c, and we have to draw the asymptotes. So there are three asymptotes: 60 degree, 300 degree, and 180 degree. Then the most important thing, breakaway point. We have found breakaway point to be imaginary. Substitute any of them in the Gshs equation and find what is the angle. And we found that angle is not a multiplicand of 180 or 360 or 540. It is not. That means all the imaginary breakaway points, they are invalid breakaway points. That means the system is not having a breakaway point. Then we have found out angle of departure at -2 plus 2j. And we have found that angle of departure at -2 plus 2j is -45 degree. Automatically we can say that angle of departure at -2 minus 2j will be plus 45 degree. That means the root locus will take a turn of negative from -2 plus 2j, and then it will be going up. It will be going up. How do we know? Because we have found out K marginal and omega marginal. K marginal we have found out to be 32. Omega marginal we have found out to be root under of 8, that is 2.82. So first mark this 2.82, and before that you had by protractor you had drawn this 60-degree angle starting from 1.33. So don't draw it just by hand, draw it by protractor. Or if you do not have a protractor, you just calculate for tan 60 how much will be the y value for x value as 1.33. So that point also you can mark. That means this is the base. How much should be the height for this angle to be 60 degree? That value you can mark here. If you don't have protractor, you can do like that. So first draw the asymptote 1 to be 60 degree, and third asymptote to be 300 degrees. Second asymptote is 180. That's not a problem. After drawing the asymptote, finally you are finding that the crossover frequency is above that. Okay, so connect this phi d with a -45 angle, then it will be going up, and it will be cutting the j omega axis at 2.82 radian per second at the top. For the bottom, it will be going up with plus 45, then it will cut the j omega axis as minus 2.82. So this is the whole root locus, and you can write down at step number 9 this kind of conclusion, that is system is stable for k in between 0 to 32. System is marginally stable for k is equal to 32, and system is unstable for k greater than 32. And all those things you have found out from this Routh-Hurwitz criterion table. So this numerical I will upload today. That